Good evening, everybody. My name is TravisShaddox. This is Turfgrass Epistemology. Thanks so much for joining me tonight. We're going to get started quickly. This channel explores how we know what we know about turfgrass science. By looking at the scientific literature, we can start to kind of crack open that little difficult to see and view shell. So we're trying our best to use the evidence we have through the scientific literature to base our management decisions on. And that's what this channel does. We've been going over soil testing the last month or so. We're going to continue to go over soil testing for a while. That's sort of my area of specialty. That's my area of interest. And 9, 10, 11 months into this thing, and I'm just not getting to the stuff that I like. But that's okay. And we've been going over base cation saturation for about the last 3 or 4 weeks. We're going to do a little bit of that tonight with calcium-magnesium ratios on Bermuda. And we'll continue. Don't forget the Monday morning members only show is still live on Monday mornings at 10 a.m. And I'm doing a Tuesday morning show at 10 a.m. that's open to the public. And it's only a video comments show. So I just show a video that happens to come on my YouTube algorithm somewhere. Usually on soil testing is what I've been going over here recently. And I just watch the video live and comment on it as the video is playing. And there's no script. I'm just showing it. And apparently it's interesting to people. I mean, that seems to be the most watched episodes, or the Tuesday morning shows about the videos that I go over and comment on. So, and then of course, Thursday night. Remember, this month is August. This is the last month for the Thursday night show being on Thursday night. So it'll be all the way on Thursday night for the rest of this month. And then in September, I'm moving it probably to Tuesday night because Thursday night football. That's the only reason. So I watch Thursday night football, and I love turfgrass, but you know, priority for me on Thursday night is football. So September we'll just move it to Tuesday evening, and so we'll do a Monday morning show, a Tuesday morning show, and then a Tuesday night show, and then I'll probably change it back in January or February or something when the football season's over or something like that. Okay, so as I mentioned, we're going over tonight a paper on calcium to magnesium ratios in Bermuda grass. This wasn't the only objective of this paper, but this was one of many objectives or hypotheses that this particular author tested. But I wanted to briefly explain or introduce what the problem actually is. The idea behind it, this calcium magnesium in the soil needs to be a certain ratio to each other, came around through a scientist in the 1880s, 1890s named Oscar Lowe. And he just sort of hypothesized that the calcium magnesium should be whatever it should be. And that then evolved and developed into the base cation saturation ratios, where we're trying to balance calcium, magnesium, potassium on the soil exchange site in the 40s and 50s. That sort of was developed in the 60s. And decade after decade after decade, it's continued to be used, and decade after decade after decade, the evidence in the literature refutes it over and over and over and over. And then around the 1980s, maybe you might be able to find a paper before then, but around the 1980s or so, we started looking into this. The scientists started looking into calcium, magnesium, and base saturation in turf grasses. Okay, so that's where we are today. We're going to start looking at the calcium magnesium in turfgrass systems with the 93 paper from Sartain tonight. Okay, but the reason it's important is because the calcium magnesium ratios are not really important, but yet they continue to be used by companies to convince you to buy their products that you probably don't need, such as gypsum or maybe lime, or magnesium sulfate, or whatever the case is, potassium, or whatever it is. And there are cases where the application of those elements may be beneficial, but it's not a result of balancing one to the other. It's the result of applying an element that was deficient. In tonight's paper, you may have heard me say many times that it's a response to potassium is pretty rare. It's in the literature, you can find it. The response to magnesium is quite rare as well, but you can find it. And tonight's paper is one of those papers where there's going to be a response to potassium and to magnesium, but it has nothing to do, and the paper makes this clear, it has nothing to do with the ratios. It was simply applying an element that was deficient. All right. However, before I get started, the response, I think it was particularly to magnesium, only occurred when the soil magnesium was low and the turfgrass clippings were removed. When the clippings were returned, there was no benefit to applying magnesium, even on low magnesium soils. Okay, so we'll get started. That was the introduction. So it's important because a lot of people use this to con you into using products that you probably don't need. And you can see it all over the place. You can just type in calcium magnesium ratios and you'll see companies talking about how it's magical and you have to balance one versus the other and how magnesium results in tight soils and all these other things. And so it is really a serious problem. And in fact, you'll see conversations about calcium magnesium even on the turfgrass, what do you call them, forums or message boards. There you go. You'll see conversations going back 10, 15 years on the turfgrass message boards about people just wanting to know, is there anything to this? And you'll see responses from people saying, I don't think so. And you'll see responses from people saying, yes, it's clearly obvious that calcium magnesium is important to balance out correctly. Okay. So I am convinced that it's not important, but the question is why am I convinced, or how do I know? I would argue that I don't know 100% for sure, but I am convinced because the evidence in the literature has convinced me. It's very compelling information. Okay. Okay, here we go. So the title of today's paper is Interrelationships Among Turfgrasses, Clipping, Recycling, Thatch, and Applied Calcium, Magnesium, and Potassium by Jerry Sartain in 1993. This was published in one of our top-tier journals, Agronomy Journal. You can view the abstract for free by going to agronomy.org and searching for Sartain or this title. And you can read the paper by joining the Tri-Society, the Agronomy Society of America, Crop Science Society of America, or the Agronomy, Crops, and Soils, Soil Science Society of America. You can download this paper as well as many thousands of other papers. Turfgrass clippings are composed of varying quantities of cellulose and lignin, which influence the rate of decomposition. Now, for anybody who really is a sadist, go back and look at the playlist of my channel, and there's a playlist for Thatch. And you will see me for a month basically self-torturing myself, going over Thatch, because Thatch at the time was a topic that was recommended to me by the audience, so I went over it for a month, and it drove me nuts. Okay. And I think I went over this paper during that month, but from a Thatch perspective. Okay. And this paper has a lot of Thatch information in it, but he's going to talk a little bit about Thatch in the introduction, which I'm not going to go over. Potassium is a primary essential nutrient for turfgrass production, but in some cases, potassium fertilization has been shown not to influence Bermuda grass growth. Barrios and Jones in 1980 shown that, and I've shown the Snyder and Cesar paper. It didn't show anything. There's a few papers. There's no question. There's a few papers that will show a benefit to applying potassium, but it's usually in a very specific situation, and it's almost always when potassium is very low in the soil. However, in other studies, Bermuda grass rhizomes, roots, and stand have been positively influenced by potassium applications, and he has the Kiesling paper from 1979 cited. Some of this inconsistency in response may be due to the soil potassium status. I would say probably all of the inconsistency is probably due to the soil potassium status. If you have enough, you have enough. Whether what the number is to be enough, that might differ based upon various turfgrass and environmental factors. In other words, you might need a little bit more at some times of the year on some turfgrasses than at other times of the year on other turfgrasses. But the soil potassium status can give you an indication. Bermuda grass disease incidence has been related to tissue potassium concentration. Midsummer tissue potassium levels of 6 grams per kilogram, which is 6%, I think 6% or less, were associated with the progressive severity of helminthosporium. Helminthosporium. So the issue with potassium with disease is basically this. There are cases when it's very, very low that it might be beneficial, but there are very clear and probably, I'm not a potassium disease specialist, but there's probably more evidence in the literature that applying potassium to turfgrass growing on soils that is already well supplied with potassium actually results in more risk of disease than less risk, more stress to the turf via disease incidence than less stress. It's only when the turfgrass is growing on soils that are low and the soil is low in potassium that there may be a benefit to applying potassium. But that'd be the case with any element. If any element was below a critical level, then supplying that element would likely alleviate whatever stress that the plant is encountering from that element. Okay. But throwing out potassium just because we've always done it, just because the marketing says it's a winterizer, is probably not a good idea. It's definitely not a good idea financially, but even agronomically, the idea that it's not going to hurt anything is not true. We've gone over that. Did I go over potassium for a month? I don't remember. But there are many, many papers that show that the application of potassium to turfgrass growing on potassium-sufficient soils is a problem. You don't want to do that. But in some cases, when potassium is deficient, it can be beneficial. G.C. Horn in 1965 reported that potassium sulfate and potassium carbonate were superior potassium fertilizer sources for Bermuda grass. More recently, Snyder and Cesar in 1990 found no growth response relative to potassium source. Okay. Oh, was I off on that, Chuck? I might have been off on the math. Yeah, definitely don't go by my math. Okay. I mean, I have conversion issues going on in my head, and I'm not always correct. So please don't go by my math. You're probably right, Chuck. Whatever the math is, what it says is what it says. It sounded odd to me to be 6%. I was like, what is 6%? That sounds awful high. So it's probably 0.6%. Thank you, Chuck. So back on the potassium sources, I'm interested in potassium sources, and G.C. Horn reported that there were superior sources on Bermuda grass for potassium. And there's this ongoing belief that centipede grass will respond more favorably to, say, potassium sulfate than it would to potassium chloride and various other, wives' tales. Or I would just call them hypotheses or observations. And we're going to start investigating that this fall, actually, because I can't find it anywhere in the literature where various potassium sources were applied to centipede grass to see the difference in response to these potassium sources, whether it's due to the salt effect of potassium chloride or the alleviation of sulfate from the potassium sulfate or whatever it might be. We're going to start looking into that and actually, come up with some sort of evidence one way or the other if in fact there is a superior potassium source to apply to centipede grass. And they showed that on Bermuda grass. It's possible. In general, we really don't see much difference between potassium sources because we really don't see any response to applying potassium. Okay, that's generally the reason. Bermuda grass has been shown to grow aggressively at very low soil pH. However, thatch accumulates excessively below pH 5.0, except in the presence of applied calcium. So what he's saying there is that there's Bermuda grass studies that have been shown to Bermuda grass grows exceedingly well at 3.5. 3.5. Very, very, very low. But those are in soils that don't have appreciable amounts of aluminum or zinc or manganese or some toxic nutrient that would become more soluble at those pHs. But thatch sometimes will actually be accumulated at greater quantities at these lower pHs. And the overriding sort of belief is, and I think it's probably correct, is that the microbial degradation that is necessary to break down that thatch simply is lower. The rate is lower at those lower pHs because the microbial activity tends to decline at those low pHs. Low soil pH is generally associated with low levels of soil calcium, and the effect of calcium application on thatch reduction may be due to a change in the pH of the thatch microenvironment rather than a calcium effect itself. And this is a critical issue to understand when it comes to understanding how calcium-magnesium ratios sold by companies is flawed, is wrong, how base count saturation is errant, how the people selling it are indoctrinated and delusional, because oftentimes what they'll rely upon to convince others is a study, a faux study, or whatever it might be, of applying calcium and seeing response. But they don't recognize that, and in every case that I'm aware of, the studies that show beneficial response actually adjusted the pH, but the investigators didn't account for the change in pH. Why? Because the original investigator who started this whole BCSR thing didn't, in his books, he says pH is not that important for plant growth. So what he says in his books, the Albrecht papers, he misunderstood the influence of what he was looking at. He was looking at a positive response and he said, it's calcium saturation, when in fact he was adjusting the pH up and he didn't recognize it. So when the authors say right here, low soil pH is generally associated with low calcium levels, and that Thatch reduction may be due to a change in the pH. In other words, when you apply calcium under these situations, you might see a response to applying calcium. But what this saying is that it's probably due to adjusting the pH upward at these lower pHs. Okay, be aware of that. And again, one of the many, many reasons why I do not encourage people to go out and do their own research. Do not encourage you to do that unless you're formally trained or have some sort of. You don't have to have a degree. But you have to know how to properly conduct research. You have to know a little bit more about the moving pieces that exist in order to develop and design a properly conduct this and properly conduct the study. Otherwise, you're going to end up with a result that you're going to be really convinced is true because you did it, but it might be flawed. Biennial lime applications have been shown to reduce thatch accumulation. So there's a benefit of applying lime, particularly on low pH soils, is a reduction in thatch. Fertilization with magnesium has been shown to have little effect on the magnesium status of tall fescue. That's true. It's had little effect on the magnesium status of St. Augustine grass too. So I think that was one of my papers that I published years ago. Whereas potassium fertilization reduced the tissue calcium and magnesium and increased the potassium concentration. And this is West and Reynolds paper 1984. And that's been since shown to be the case in many other studies, particularly by Miller and by other scientists who have looked at the tissue concentrations as it is a result of applying one cation and it changes or reduces the concentration of other cations in the plant tissue. Okay, so again, another reason why I just don't recommend going out and doing anything unless you have a good reason, because if you're not potassium deficient, applying potassium might result in many other unintended consequences that you were unaware of. And then you suddenly go, I got a big outbreak of microdocium, and then you're out applying fungicides. Meanwhile, you're applying fungicides, this is hypothetical, you're applying fungicides because you applied potassium and that resulted in the increase of microdocium. That actually can happen. That part is true. I'm just saying that could happen. Okay. So be careful. There's more things going on than just, there's no harm in applying potassium. There's no harm in applying calcium. Go ahead and do it just to make sure that I'm covered. They can actually cause a cascading effect of unintended consequences. Interrelationship of the effects of calcium magnesium on plant growth has been studied on various crops. Lehman 84 found the optimum soil calcium magnesium ratio to be 2.5 for tomatoes. That is one plant that there may be a little bit there because but I don't know tomatoes, but I've read a couple papers on tomatoes, and there may be something there with tomatoes and calcium that we need to account for. Okay. Veronin and Banter in 1985 failed to obtain a response to herbage growth relative to the soil calcium magnesium status. Bermuda grass growth rate was not reduced in the presence of a 100-to-1 soil extractable calcium to magnesium ratio in 1985. So there's another study in 85. We'll go over that paper probably next week. That's Sartain's other paper, his earlier paper. 100-to-1 calcium magnesium ratio, and there was no problem with that at all. The purpose of this study was to evaluate the influence of clipping return on potassium, calcium, magnesium applications on thatch accumulation. Thatch accumulation, clipping yield, and visual turf quality of Tifway Bermuda grass and pennant ryegrass. Amendment effects on soil extractable levels of potassium, calcium, and magnesium also were examined, along with the effects of the soil extractable calcium magnesium ratio on clipping yield. Okay. Studies were initiated in 1985 and conducted over a 3-year period at the Turfgrass Field Laboratory near Gainesville, Florida, on an Arredondo loamy fine sand with an initial pH of 6.3 and a CEC of 11. Now, the base cation saturation fraudsters and quacks will claim that base cation saturation is not useful when the pH drops down, when the CEC is low. And because they're not basing any of their beliefs on evidence, they can't even get their BS correct. Sometimes they'll say 7 or 8 or less, it doesn't work. And then sometimes in their books, they'll say, well, 10 or less than base cation saturation doesn't work. And so they can't even get their own misinformation aligned correctly. But in this study, I highlighted this because this study is greater, the CEC in this study is greater than the misinformation perpetuated by these fraudsters when they say it must be greater than 7 or 8 or it must be greater than 10. Well, this one's 11. Okay, so this article qualifies to be counted even in the BS base count saturation world. I would assume they would have to include this article. They can't deny it. Basically, what I'm saying is they can't deny it based upon the CEC being too low, because the CEC here was 11. In November of each year, dormant Tifway Bermuda grass was overseeded at a rate of 122 grams per square meter with pennant perennial ryegrass. The Bermuda grass was approximately 5 years old at the beginning of the study. So now they can't use, it was a new grow-in. It wasn't an established turfgrass sward, so it won't work. Well, this was 5 years old, so I would definitely consider that to be established. Nutritional treatments of calcium, magnesium, potassium were randomly arranged in the main plots, and clippings returned or removed was stripped across the main plot. So this was a split plot, if anybody wants to know. Calcium, magnesium, and potassium were applied at 0 and a little less than a half a pound, so 2/5 of a pound. So it was applied at, what would that be? It'd be 0.4 pounds, basically. So calcium, magnesium, and potassium were applied at 0.4 pounds per 1,000 square feet every 2 months as calcium sulfate, magnesium sulfate, and potassium sulfate. And if you've ever heard me say, good morning, Randy. Woke up early. Okay, thanks. If you've ever heard me say, well, you can't really measure, at least easily, you can't measure the effect of calcium or magnesium or potassium if you're applying it with a sulfate, because the sulfate's more likely to cause a response than the cation. So, and then you see in this study, this study applied calcium sulfate, magnesium sulfate, and potassium sulfate, so this wouldn't be useful. But let's watch what a scientist who knows what he's doing. Let's see how he sets it up. Nitrogen was applied uniformly every month as ammonium sulfate at that would be 0.2 pounds. 0.2 pounds per 1,000 square feet every month. So what the scientist did was that he applied sulfate to all the plots, including the non-treated plots, so that any difference between the non-treated plot and the calcium sulfate plot would be due to the calcium, because he applied sulfate to both plots. Okay? Concentrated superphosphate was applied to all plots at 0.2 pounds of phosphorus every 3 months, and then he applied micronutrients to make sure they were not deficient, and across everything. Those were blanket applications across everything. Clippings were removed and discarded from one half of each plot, and clippings were not removed on the other half. Visual quality ratings were taken. Now you have to remember, before I get too far, before I forget, back in the 80s, actually I'm going to say probably around, I would say, I was mowing lawns, pushing mowers in the 1980s, and I stopped around 89 or 90, something like that. But back then, we were bagging all the clippings off of lawns. I was pushing that mower with a trash can on top of the mower, and I'd bag all the clippings and I'd put them out by the road, and they would remove the clippings. So he's conducting this study at a time when it was very common to remove clippings, and it was thought that the addition or the leaving the clippings behind might actually be a problem. They weren't even thinking that they might be beneficial. They thought that they were it's either going to do nothing or it'd be a problem. Okay, so keep that in mind, because that's why the study was being conducted. Remember, this was 93, so it was conducted in, what year was this conducted? He did this in 1985. Okay, so this is right in the middle of collecting clippings off of lawns and off of fairways and roughs. I mean, it was, that was very common back then. Visual quality ratings were taken every 2 weeks on a 1 to 9 scale, with 5.5 being minimum acceptable. Visual quality was a composite of turfgrass color density, uniformity, etc. Bermuda grass clippings were harvested in June, August, and October, and ryegrass clippings were harvested in January and February. I don't understand Western Mass law of return. I'm sorry. I'm not sure what you mean there. Sorry, Western Mass. Soil samples 1 inch by 6 inches deep were taken from each plot in October at termination of the study, extracted with Malic 1 and analyzed for K, calcium, magnesium. Pretty straightforward study. I mean, he's looking at removing clippings, leaving clippings. He's looking at adding calcium, magnesium, potassium. He's looking at the ratios. He's looking at yield or quality and thatch accumulation, looking at all these various things. And the key, the primary objective was looking at thatch, but what we're interested in tonight is what he actually found and concluded on the calcium-magnesium ratio. And we'll do that again next week with his other paper in the 80s. Mean clipping yield of both Bermuda grass and ryegrass was increased by the return of clippings. Now, you have to remember, I mean, when we read this now, you're going to go, well, yeah, of course. Of course it's going to go up because you're returning clippings. But they didn't know that back then. It's in the middle of the 80s. Everybody's removing clippings. Everyone. Maybe not sod production or something, but I mean, golf, sport turf, lawn care, we're removing clippings in the 80s. And one of the first sentences in his results and discussion were mean clipping yield of Bermuda grass and ryegrass was increased by the return of clippings. So we know immediately there's probably a nutritional benefit to returning these clippings. Okay. Good evening, Esteban. Bermuda grass and ryegrass clipping yield was increased by 27 and 20% respectively by the return of clippings. Table 1. We'll go up here and we'll see table 1. And you'll see we're going to look at, all we're looking at here is comparing clippings versus no clippings. That's all this table does. If I can get it on here. And you can see clipping yield, Bermuda grass and ryegrass, clipping in content, Bermuda grass and ryegrass, and visual quality, Bermuda grass and ryegrass. And we see the clipping yield was, when it was returned, was 5.1. When it was not, it was 4. And that was a significant difference, both and biological difference. And you can see the difference. Ryegrass, there was an increase when it was returned. Clipping nitrogen content was increased when it was returned. Ryegrass nitrogen content, everything except ryegrass quality. There wasn't a benefit to ryegrass quality, but everything else was. Bermuda grass quality, this is biologically insignificant, 6.8 to 7.1. No one would ever be able to pull that out with the eye. But there was a statistical increase there. So there was a benefit. So in the 1980s, he's saying, well, not only is there not a disadvantage to applying mulch or applying clippings, returning clippings, there's actually a benefit to applying returning clippings. That wasn't common knowledge back then. Ryegrass quality was unaffected by clipping return. That's what I just said. Weight loss on ignition was not increased by the return of Bermuda grass clippings, except in the 3 to 5 centimeter zone. Approximately twice as much thatch was observed in this zone on plots receiving clippings in comparison to plots from which clippings were removed. Overall, however, the mean weight loss on ignition was not influenced by clipping return. So he separated out the soil depth, and in one area, he actually found that there was a little bit of increase in thatch as return of clippings. But overall, there was no increase of thatch because he returned the clippings. And remember, back then, that's what the people thought. Even today, a lot of people think that. And it seems like the overriding consensus is that it does not increase turfgrass thatch. The return of clippings does not increase turfgrass thatch because clippings do not contain a large quantity or percentage of lignin, and it's the lignin that is very difficult to decompose. It takes a very, very long time to break down that lignin, and the turfgrass leaves don't have hardly any lignin in them. There's usually cellulose or hemicellulose, which is easily broken down by the microbes in the soil. Okay, well, I have a playlist on thatch, and you can go back and watch all you want. But I'm not going to, but you feel free. The addition of potassium and calcium did not promote additional thatch accumulation. So potassium and calcium did not. Okay? Since the calcium in this study was applied as a neutral salt, being gypsum, no change occurred in the soil pH, and the addition of calcium does not appear to promote thatch accumulation. This was not known back then, okay, guys and gals? The application of magnesium to plots from which the clippings were removed increased the quantity of thatch. So keep this in mind. You're going to see magnesium influence here several times, actually. And it's critical that we understand the context. He's saying the application of magnesium increased the quantity of thatch. You're going to see an increase in other things as well. But it was when the clippings were removed. I'm going to show you the soil concentration of magnesium that he started with, which was very low. And then you're going to see what happens when he applied magnesium. But keep in mind, it only occurred when the clippings were removed that the application of magnesium was beneficial. The effect of magnesium addition on thatch may have been a result of increased growth and not a direct effect on the thatch, and that's probably the case. His data support that. Turfgrass clipping yield, nitrogen content of clippings, and visual quality were influenced positively by the return of clippings. No increased incidence of disease or insects were noted on plots receiving clippings. So again, we have to keep in mind, transport yourself back to 1985, and no one knew this stuff. Okay, I wonder how many people in the audience who were working back then were removing clippings in 1985. There may have been a few. There may be a few here tonight. We have some senior people like myself. You may have been removing clippings. I wasn't. I bagged up, I don't know how many hundreds, maybe thousands of bags of clippings off of home lawns. Very, very common. But if you left the clippings in place back then, the evidence later on determined that, in fact, you were probably doing the right thing. You were doing the right thing. And there's really not any disadvantage other than the clippings that are left behind. There wasn't any mulching blades probably back then. So you do see the clippings there, but you were doing the right thing. So kudos to you if you were returning clippings in 1985. In fact, no disadvantages were observed other than the presence of clippings on the plots for a short period of time after mowing. Thus, the practice of returning clippings on a putting green would not be practical. So putting greens, that wouldn't be tolerated. Applied nutrients. Okay, for the applied nutrients. Two areas of interest in the study were to determine the acceptable ranges of soil extractable calcium and magnesium for unrestricted turfgrass clipping yield and quality, and to evaluate the relationships between clipping yield and the soil calcium-magnesium ratio. So all he's saying is, one of the objectives was to determine what is the acceptable range to maximize growth and quality. What is the range? What is the calcium-magnesium? We need to know that. What is it? Okay. Soil samples were collected in October at termination of the study from Malik 1. That's the extractant used for calcium, magnesium, potassium. This soil was low in extractable magnesium and potassium and had a final pH of 5.0. I don't know why he doesn't say the concentration in the text. I'm going to show it to you in a table, but it's kind of hard. It's very easily looked over if you're not careful. When calcium and magnesium were both applied, the soil extractable level of calcium remained about the same as the untreated soil, and magnesium increased to a level similar to that of magnesium-only treatment. It appears that magnesium was retained in preference to calcium and that the applied calcium was lost through leaching when magnesium was applied with calcium. You're going to see a lot of that in here. I'm going to maybe have to speak a little slower so that even I don't get lost. But when two elements were applied, sometimes something happened to the third. When one element was applied, sometimes something happened to both. There's a combination. There's three combinations here, or there's three elements, more than three combinations. And things happened based upon whether there was two elements applied or only one of the elements were applied. Okay, so there was some strange sort of things happened with the element that was not applied, and he makes a point of saying it, but it's kind of, you can get lost if I speak too quickly, or I can get lost, I should say. The influence on calcium leaching was even stronger when potassium was applied along with magnesium. Okay, so if you're applying potassium and magnesium, it's going to say, oh my gosh, the calcium's leaching. Don't lose sight here, okay, of the context. You're applying two cations. One's a monovalent cation, one's a divalent cation, potassium, magnesium. You're applying just those two, and he's saying calcium's leaching through. And you might go, oh my gosh, calcium's leaching and I'm causing problems. Well, one, you wouldn't want to apply potassium or magnesium unless you have a good reason, which in this case, he did have a good reason. Both potassium and magnesium were quite low. And the turfgrass responded to both of them depending on the situation. But even when calcium leaches through, you still have so much calcium in the soil usually that it's sort of irrelevant. Okay, you wouldn't want to do it, but even if you did do it, you still got plenty in reserve, usually with calcium, okay? Potassium is a little different, okay? There's some things that you don't want to fidget with too much. But calcium's the last element on my list of things to be worried about in terms of seeing a deficiency in it, okay? Reduced levels of soil extractable calcium were observed when potassium was applied. This reduction was amplified when magnesium was applied with potassium. Soil magnesium was influenced by the application of calcium and potassium, but the addition of calcium, magnesium, or both along with potassium tended to reduce the soil extractable potassium status. The divalent nature of calcium and magnesium possibly resulted in greater retention of these nutrients in the expense of potassium. Now, you're going to get into some lyotropic series stuff here. I don't mean to, bore everybody to tears with all this soil chemistry stuff, but there's such a thing as what's called a lyotropic series. And what it does is it provides the likelihood of retention of these various cations based upon their size and their valent charge. And you can look it up in any basic soils book is going to have it. So, for example, you'll see calcium would be greater than, say, ammonium, or greater than, whatever, zinc, because this charge, it has to do with the charge and the size. So I'm sorry, this is probably a little bit more information than you wanted to know, but there's a lot of lyotropic stuff going on in these discussion. It appears from these results that when applied in combination with magnesium, It appears from these results that when applied in combination, magnesium will be retained more effectively. Essentially, listen, this is in red here. Reds are important, guys and gals. Essentially, none of the applied calcium was retained when applied with magnesium and potassium. In fact, the soil extractable calcium status of the plots receiving all three nutrients was actually less than the non-treated plots, suggesting that rather large amounts of calcium had been lost from these plots over 3 years. So let's look at this table here, and I'm going to explain what's going on here, and I'm going to show you what the original status was in the soil. So this is table 3. Now we're looking at the Mehlich 1 extractable soil levels of calcium, magnesium, and potassium. At the end of the study, we're looking at what was applied, calcium, magnesium, potassium, and we're looking at the treatment plan here. And then we're going to look at the Mehlich 1 extractable levels of calcium, magnesium, potassium. And this is going to help explain why you don't really want to go out and just start throwing stuff out because you've always done it, but you don't have a good reason to do it. This top row has 0 calcium, 0 magnesium, and 0 potassium applied. And so this was the soil's nutritional status at the end of the study with nothing was applied. 456 parts per million calcium, which is above most critical limits. Most specialists would say that's above any critical limit. Okay. But look what happened down here when calcium, magnesium, and potassium was applied. All three of these were applied. It drops from 456 down to 400, the calcium does. So you're applying all this calcium, magnesium, potassium, thinking, oh, I'm going to get my calcium up, when in reality it declined. The magnesium went up from 20 to 80, and the potassium went up from 10 to 30. But the calcium actually declined. Okay. You can see when only calcium was applied, calcium went up. Right? So you can look through here and see all the combinations of the various interactions in calcium, magnesium, potassium, and you can see what happens with the Mehlich 1 extractable at the end of the study. Okay? When only potassium was applied, potassium went from 10 to 50. Okay? But when potassium and magnesium were applied, potassium only went from 10 to 40. Okay? So there's a whole lot of stuff going on here soil chemistry-wise. You just really want to do yourself a favor and avoid applying nutrients that you do not have a good reason to apply, because you might end up just resulting in an unattended deficiency in some other element. Thank goodness it was calcium that went down, because calcium, even when it does go down, is probably not going to result in a deficiency. But imagine if it was, but this potassium, by the way, is 10, which is quite low. Imagine if it was potassium that went down. You're already low. You're already in the risk zone at a 10 part per million Mehlich 1 potassium. That number, is most of the literature is going to say that number, you're going to see a deficiency at that number. Okay. So just be careful. Make decisions based upon good reasons. Not because we've always done it, or because I heard it on YouTube, or even if I heard it in a turfgrass, conference or something. Those are not necessarily good reasons. We want to look to the literature, or to a specialist at the university who specializes in this specific area. Like if somebody calls me up and asks me about what is the potassium critical level for potatoes in Hastings, Florida, I have no freaking clue. No idea. I'm not a potato specialist. Okay, so the reason I'm saying that is when you call university, make sure you're talking to a turfgrass specialist in nutrients. Okay, one of the brightest, smartest, most successful nematologists in the world is at the University of Florida, Dr. Billy Crow. Don't call him up and ask him for a nutritional recommendation. Actually, you could ask him and he would just tell you, don't ask me. he's self-actualized enough to say, you know what, I don't know. Don't call me. I'm a nematode guy. Call someone else who's a specialist. But make sure you're talking to someone who's a specialist in these areas is my point. Not just someone who picks up the phone and might be a specialist, but in, alfalfa or something. We continue. Mean Mehlich-1 extractable potassium increased from 10 to 40 over 3 years in response to applied K. This Arredondo soil was composed of 96% sand, and the potential for creating potassium reserves was very small. In other words, you only have so much capacity to retain cations, and in this soil, you can apply whatever, you can keep applying potassium, it's only going to hold so much, okay? The ratio of Mehlich-1 extractable levels of calcium to magnesium varied from 3 to 49 across the different treatments by the end of the study. So keep that in mind, guys and gals. The ratios varied from 3 calcium to 1 magnesium to 49 calcium to 1 magnesium. That was the variation in the calcium-magnesium ratios of the soil. So now let's see what they found within those variations with regards to the turfgrass response. No relationship was observed between the clipping yield and visual quality of either turfgrass and the calcium to magnesium ratio to the soil. Yet applications of magnesium increased visual quality and clipping yields. So what he's saying is there was no influence of the calcium-magnesium ratio, but there was an influence from simply applying the magnesium. Okay? That's critical. That little 2 sentences there can slip right by you and you not recognize the power of what it's saying. It's saying that this calcium-magnesium ratio did nothing, but applying magnesium actually resulted in a beneficial response. Okay? If I had a different color, I'd color that thing even a brighter red. That's a very important concept to understand. Therefore, the maintenance of a target calcium to magnesium ratio in a turfgrass soil is of little value. I wonder how, if you present this to the BS artists and the fraudsters at these companies, I wonder what they say about this stuff. I wonder if they look at these papers at all. They probably don't look at them at all. I don't even know. But I wonder if you look at it and you present it to them, I wonder what they would say. How would they argue their way out of that? I'm sure there's an argument out of it. I'm just wondering, do they have a cogent argument and a compelling argument to counter this? Because it's dozens of these papers. This is why I have this opinion of papers like this. Maintenance of certain minimum levels of soil extractable calcium magnesium may be of more practical importance. Studies conducted by Rossi in 88 suggest that the maintenance of, and by the way, I don't think this is Frank Rossi. If those people who know Frank, I don't think this is Frank Rossi. Suggests that the maintenance of minimum critical levels of calcium magnesium is more important than the calcium to calcium plus magnesium ratio for optimum growth of winter wheat forward. So again, they're saying he's just showing other authors have found the same thing. To establish a range in extractable soil calcium magnesium, relatively large amounts of these nutrients were applied during the study. Applications of calcium, magnesium, and potassium did not influence ryegrass clippings. Bermuda grass clipping yield was, however, increased by the application of potassium and magnesium. We're going to look at that in a second. This supports the interpretation of the soil test analysis for these two elements. Now, what he's saying here is that this work validates the inclusion of these two elements on a soil test. Show me anywhere in any refereed papers, any refereed journals, specific to turfgrass, where something like that could be said for calcium, magnesium, base cation saturation, or saturated paste extract. I've never seen it. Doesn't mean it doesn't exist, but show me anywhere in a refereed turfgrass paper where something similar can be said about those philosophies. The slower growth habit and shallow rooting characteristics of annually overseeded perennial ryegrass apparently make it less dependent on the nutrient supply property of the underlying soil. So I'm going to keep going here. I'm going to look at this table. I highlighted this one here to show, let me just show this because I have been hitting potassium magnesium pretty hard on my channel, but I do want to point out that it can happen. And here's an example of magnesium and potassium resulting in an increase. This is the mean dry weight of clipping Bermuda grass as influenced by applied nutrients over 3 years. There was no influence of applying calcium, magnesium, or potassium on the dry weight of the clippings for ryegrass. You see these NSs. Nothing happened with ryegrass. And nothing happened with calcium on Bermuda grass. But for Bermuda grass, magnesium and potassium, they both resulted in an increase in the clippings of Bermuda grass from 4 to 5 grams per meter square per day for magnesium and 4.2 to 4.8. So that's probably biologically as well as statistically significant. You're looking at an increase of, several percentage points. Okay, but again, keep in mind that happened at these levels in the soil, a 20 on magnesium malic 1 and a 10 on potassium malic 1. And on this soil, this Arredondo fine sand, correlations have been conducted, relationship regressions have been conducted between malic 1 and malic 3. And I know that the magnesium and potassium, well, the potassium is basically the same number for malic 3, malic 1 on this soil. It's a 10, and I think it's like 10 point something 5 or something like that for malic 3. With magnesium, it's a little bit different. There's a little bit more magnesium extracted with malic 3 on this soil, but it's not like double. I think it's like 25 or something. It's another like 10 or 15% higher, something like that. So if it's malic 1 is 20, malic 3 might be 25. I can't remember now, but I know for sure it's not a lot. So what I'm getting at is the magnesium and potassium resulted in an increase because it was low in the soil. This particular soil was quite low in magnesium and potassium. And that can and will happen under those conditions. Okay, guys and gals. Now we go to the next little bit here, and we're almost done. I'm going to talk about, he talks about here. Okay, the visual quality of turf grasses growing on plots to which the clippings were returned was not influenced by the applied nutrient treatments. So when the clippings were returned, the quality of either turf grass never changed, whether you applied calcium, magnesium, or potassium. Return your clippings. I'm sure we all are now. I'm sure this is all standard nowadays, which is a good thing. There's more than one good reason to return clippings. And this is a very, very good reason to return clippings. The quality of either turf grass never improved when you applied calcium, magnesium, and potassium to turf grass when the clippings were returned. However, the application of magnesium did positively influence the appearance of both turf grasses growing on plots from which the clippings were removed. Okay, so let's look at this. When the clippings were removed, so I'm looking at table 5, the mean visual qualities of Bermuda grass and ryegrass, where clippings were removed over 3 years. Now, biologically, you're never, ever going to know the difference between a 7.0 and a 7.2. And you're never going to figure out the difference between a 6.5 and a 6.7, ever. So, what I'm showing here on the screen for those listening is when calcium was applied versus when calcium was not applied on Bermuda grass quality. When magnesium was applied versus not, when potassium was applied versus not, and so forth on Bermuda grass and on ryegrass. And you see nothing happened with calcium, nothing happened with potassium on either grass. But statistically, there was a difference when you applied magnesium. However, no one will ever be able to figure out that difference with the eye. This is biologically insignificant. Okay? So while technically, yes, magnesium can show a response, can show a benefit here and there. This paper is evidence of that. Potassium showed a benefit in some cases with yield. The response or the benefit is so small, it's essentially negligible with magnesium. Okay? Even on magnesium soils with magnesium levels of 20 Malic 1. As long as the clippings were returned. When they were removed, even then, there was no difference. Really. No biological difference. Okay, so even when you removed them on low magnesium soils, I bet I can just scroll up here, right here. Even on this soil with 20 parts per million magnesium, 20 parts per million magnesium, even when the clippings were removed, meaning you're harvesting magnesium out of the soil. The turfgrass is a harvesting machine, okay? It's taking nutrients out of the soil and it's putting them in leaf tissue. And if you're removing that leaf tissue, you're removing the magnesium and everything else in that tissue. So over time, over however many years, you would expect to see that magnesium level go down and down and down and down. But even in those cases, we did not see any biological benefit, only statistical. Okay? I want to make sure that's clear. Limiting supplies of soil magnesium, especially on plots having very low magnesium levels, 14 to 18 parts per million, were possibly augmented by the applied magnesium, which resulted in a higher visual quality rating. So he's just postulating that's what probably happened. It's true. In summary, the return of clippings does not appear to negatively impact Tifway Bermuda grass. In fact, clipping yields and visual quality are enhanced by their return. Potassium and magnesium additions promote clipping yield while depleting soil extractable calcium reserves. And then the final sentence of the summation is this: Bermuda grass and perennial ryegrass will tolerate a wide range in soil calcium to magnesium ratios without exhibiting detrimental effects. And there are at least 2 or 3 other papers that show this exact same result on turf grasses, on non-putting green turf grasses. Low magnesium, low potassium, low calcium, and the ratios didn't matter. On soils with the CEC greater than the fantasy range of 10 CEC or less than 8 CEC, when you hear people say, "Oh, it's 7 or 8 or below, it's no good. 10 or below, it's no good," just ask them, "How do you know? Show me some data." They just pull these numbers out of thin air. Well, I've been doing it for 40 years. We've been doing it for 40 years. And it works. I don't care how long you've been doing it. You know how many millennia humans thought the earth was flat? Every human on the planet thought the earth was flat for thousands and thousands of years, and they were all wrong. I don't care how long you've been doing it wrong. What I care about is the evidence that we currently have. Is there a consensus? Hopefully, if there is a consensus, I'd prefer to follow that among scientists. If there's not a consensus, I'm going to use the literature to help guide me as best I can. And maybe that's wrong too. You don't know, but I'm going to use that as best I can. The chances are, the odds favor that that is more likely to be correct than, traditional usage or historical usage. Okay, those are flaws. Okay, guys and gals, we have a minute or two. Let me go back through the chat and see if I miss any questions, or if you want to throw in any questions, I'll take a minute or two before I step away. And while I'm looking through the chat to see if there's any questions, don't forget, Monday morning we'll have a members only stream again. Tuesday morning we'll have a video comments show. Both of those will be at 10 a.m. And then I'll have the same show next Thursday night at 9 p.m. Yeah, so Mike Conroy, real quick, I got your email. Sorry, I didn't reply, but you saw my response. Yes, that's definitely turf type tall fescue seed heads. You got something going on there, but that's interesting. I'm just scanning through oh yeah, so my wife was here. As you can tell with the 3 Brazilian flags, she's Brazilian. Oh, Connecticut Cubanican threw in a Brazilian flag too. Nice. So, oh yeah. So the Earth's not flat. Yeah, no, the Earth's not flat as far as I can tell. Okay, so let me see if I can get Mike's question here. Don't we all do, okay, so Mike Connery, don't we all do this for the visual quality? If no significant change doesn't matter. I'm not sure what you mean, Mike, but I think you're talking about just removing the turf clippings for the quality, for what it looks like. Or I'm assuming. No, you're talking about returning the clippings. Returning the clippings for the quality. And then you say, if no, I'm not sure what you mean by that. I'm sorry, Mike. I'm missing your question there. If no significant change doesn't matter. You have to follow up with an email with me, Mike. Maybe I can answer your question. All right, guys and gals, I'll let you go. I'll see you on Monday morning, and I hope you have a good weekend. And thanks for showing up. I appreciate everybody who comments and participates in the chat. Thanks a bunch. See ya.